Hey everybody, since I'm going to be out, I thought I should probably take questions from homework 40 by doing homework 40 with you. So I'm going to do homework 40. It's on pages 124 through 126. And we start off with problem 11, and we're using our derivative shortcuts here. The problems start off fairly straightforward. Y equals x to the fourth minus 4x squared plus 1. And so we know that y prime, or we could call it dy dx, y prime will be the derivative of this, which is 4x to the third, minus the derivative of this. So I bring down that 2. 2 times 4 is 8. I subtract 1, I get x. And the derivative of a constant is 0. So here's my y prime or dy dx. Okay, next. 12. 12 is y equals x to the fourth minus 7x to the third plus 2x squared plus 15. So y prime or dy dx will be the derivative of x to the fourth. We bring down the 4, we subtract 1. We bring down the 3 from negative 7x to the third, and we'll have negative 21x, subtract 1 to the second, plus we'll bring down that 2 and have 4x, and the derivative of a constant is 0. With number 13, we have an opportunity to use the product rule I did in an earlier video. If you went to the CPR class, you probably saw we've got x plus 1, x squared plus 1. Now, this problem, we're asked to do this problem two different ways. The first way, part A, with the product rule. So y prime will be this times the derivative of that. So this, x plus 1, times the derivative of that. And the derivative of x squared is 2x. The derivative of 1 is 0. Plus, we were only halfway done with the product rule, this x squared plus 1 times the derivative of that. Well, we know the derivative of 1 is 0, and the derivative of 1x is 1. So if I tidy this up, I'm going to have 2x squared plus 2x plus x squared plus 1, which is 3x squared plus 2x plus 1. They also asked us to do this problem in part B by actually foiling it out. So I get y equals x to the third plus x squared plus x plus 1. And so y prime is simply the derivative of each of these pieces, 3x squared plus 2x plus 1. Derivative of 3x squared, of x to the third is 3x squared. The derivative of x squared is 2x, because I'm bringing down that 2 and subtracting 1. The derivative of 1x, look, this is a linear function. The slope is always 1. So therefore we have plus 1. And the derivative of a constant is 0. So there's problem number 13 in all its glory. Problem 14 asks us to use the quotient rule. 14. We've got y equals x squared plus 3 over x. And again, they ask us to do this problem two different ways. The first way is with the quotient rule. Remember, the quotient rule is low, d high, the derivative of this stuff will be 2x, minus high, x squared plus 3, d low, the derivative of x is 1, all over low squared. So up top, I'm going to have 2x squared. Don't forget to distribute this negative, minus x squared minus 3, all over x squared, which is x squared minus 3 over x squared. Okay. They also asked us to consider this problem by simplifying, rewriting this as a sum of terms. So y, we started off with x squared plus 3 over x. But now we're going to rewrite this as x squared over x plus 3 over x. Now, here, I can simplify this just to be x. But here, I'm going to flip this up and make it 3x to the minus 1. So now I haven't taken any derivatives yet. I've just been doing some algebra. It's time to take the derivative y prime of this. The derivative of x is 1. And the derivative of 3x to the negative 1 is going to be the derivative of x to the minus 1 times the constant 3. So bring down the negative 1 and subtract 1 here. Negative 1 minus 1 is negative 2. This is the same as 1 minus 3 over x squared, which, if we take this, our part A answer, and split it into two fractions, we see that we also have 1 minus 3 over x squared. Okay? So these are the same answer, and we need to be able to recognize that for multiple choice problems. Okay? Multiple choice could be comfortable with either of those representations of the answer. Okay, 15. 15, we just have to take the derivative. They tell us that y is this product, x to the third plus x plus 1 times x to the fourth plus x squared plus 1. And here we're going to say that y prime is this times the derivative of this. The derivative of x to the fourth is 4x to the third, plus the derivative of x squared is 2x. Remember, we're not done. We're only halfway done with the product rule. Now we need plus this, x to the fourth plus x squared plus 1, times the derivative of this stuff. Well, the derivative of x to the third is 3x squared, plus the derivative of x is 1. I'm not going to take the time to FOIL this out. I'll let you do that if you like. I'm just going to move on to the next problem, number 16. Number 16 says, 16, y equals x squared plus 1 times x to the third plus 1. Okay, so this is a product rule. Y prime is going to be this, x squared plus 1 times the derivative of this, which is 3x squared, plus this, x to the third plus 1, times the derivative of this, which is 2x. I don't mind distributing and combining like terms here. It's not as heinous as that last problem. 3x squared plus 2x to the fourth plus 2x, and I see 5x to the fourth plus 3x squared plus 2x. Okay, there's our first. Yeah, I think that's good. All right, so there's 15 and 16. Let's take a look at 17. 17 is a quotient rule problem. Y equals 2x plus 5 over 3x minus 2. Remember, y prime is low, d high. 3x minus 2 times the derivative of the stuff on top, minus low d high minus high d low. The derivative of this bottom function is 3, all over 3x minus 2 squared. Low d high minus high d low over low squared. And if we tidy this up, we'll have 6x minus 4 minus 6x minus 15 all over 3x minus 2 squared. These don't always cancel, so don't expect them to, but they do certainly here. 3x minus 2 to the second. There's our y prime, number 17. Okay, let's take a look at 23. The directions for 23 say Wow, what's that? There's all this stuff here. Suppose that u and v are functions of x that are differentiable at x equals 0, such that u of 0 is 5 and u prime of 0 is negative 3, and v of 0 is negative 1, and v prime of 0 is positive 2. Ooh, I feel like I'm going to need that information. I think I'll make a handy graphic organizer. Oh, mercy. Okay, so we've got some functions, u and u prime and v prime, and we want to know when x equals 0. So they told us that u of 0 was 5, and that u prime of 0 was negative 3, v of 0 was negative 1, and v prime of 0 is positive 2. And then they ask us to find some derivatives given this information. Okay, so we're going to be using this information in parts A, B, C, and D. Part A, for number 23, says d dx u v. Well, remember, this is the imperative form of the verb, take ye the derivative of this product with respect to x. Well, luckily, these are functions of x, and so all we have to do is the product rule. This times the derivative of that, plus this times the derivative of that. And really what we're doing, since we want to know d dx at x equals 0 of u times v, we're really looking at u of 0 times v prime of 0 plus v of 0 times u prime of 0. Well, u of 0 is 5, v prime of 0 is 2, v of 0 is negative 1, and u prime of 0 is negative 3, and so I end up with 13. The derivative of u times v at 0, the derivative of u times v at 0 is 13. Let's take a look at B. B here says the derivative of u over v. How surprising. The derivative with respect to x of u over v. Well, there's the quotient rule. Low d high minus high d low all over low squared. So if we want to evaluate this derivative, d dx u v at x equals 0, that's going to be v of 0, which is negative 1, u prime of 0, which is negative 3, minus u of 0, which is 5, and v prime of 0, which is 2, all over v of 0, which is negative 1, squared. And so I get 3 minus 10 over 1, or negative 7. All right, so the slope of this u over v function at x equals 0 would be negative 7. Let's take a look at part C. I wonder what part C will be. We've already done product rule and quotient rule. Part C says the derivative of v over u, the derivative with respect to x of v over u. Okay, so we know that's low d high minus high d low all over low squared. So when we evaluate, we're going to have 5 times 2 minus negative 1 times negative 3 all over u of 0 squared. So I've got 10 minus 3 over 25, which is 7 over 25. And then finally part D. Part D asks us to consider 7v minus 2u. The derivative for part D is 7v minus 2u. I think I wrote that down right. Yes. So, well, this is pretty straightforward. This is just going to be the derivative of 7v, a constant times v, so 7v prime, minus the constant times the derivative of u prime. So I've got 7 times 2 minus 2 times negative 3, which is 20. You could use product rule here and product rule here, but you're crazy. Don't do that. This is a constant times a function. So when you have the constant times the function, y prime will always be that constant times the derivative of the function. Don't do product rule here. Don't do product rule here. You're crazy if you do. Just do the derivative of v and slap on that constant. Just do the derivative of u and slap on that constant. Okay, there's 23. Let's take a look at 24. It looks to be the same type of problem. Yes, they gave me some more information. Kukla just must want me getting very comfortable with product and quotient rule. This time the derivative is going to happen at x equal to 2. And we've got u of 2, which is 3. We've got u prime of 2, which is negative 4. We've got v of 2, which is 1. And v prime of 2, which is 2. And they'd like us to find in part A the derivative with respect to x of u times v. So this is the product rule, and we know this is going to be u times v prime plus v times u prime. Or when we evaluate at x equal to 2, the derivative with respect to x of uv evaluated at x equals 2 will be 3 times 2 plus 1 times negative 4, which is positive 2. What about b? Quotient rule, u over v. The derivative with respect to x of u over v. Well, we know that derivative will be low d high minus high d low all over low squared. And so when we evaluate this derivative, we'll plug in our v, we'll plug in our u prime, minus our u times our v prime, all over v squared. So I get negative 4 minus 6 is negative 10. Part C, they ask us to do the derivative of v over u. Derivative with respect to x of v over u will be low d high minus high d low over low squared. So when I evaluate this derivative at 2, I'm going to have 3 times 2 minus 1 times negative 4 all over u of 2 squared, which is 3 squared. So I end up with 10/9. And D, for 24D, they tell us 3u, the derivative with respect to x of 3u minus 2v plus 2uv. Okay, so there's a product rule times a constant. So just slap that constant on when you're done with the product rule. Okay, the derivative of 3u will be 3u prime. The derivative of minus 2v will be minus 2v prime plus 2 times, and the product rule, u times v prime plus v times u prime. Okay, let's plug in our values. 3 times -4 minus 2 times 2 plus 2 times u of 2 is 3, v prime is 2 plus 1 times -4. Okay, so I get 6 minus 4 is 2. 2 times 2 is 4. Here's -4, and here's -12. And so that derivative is -12. All right, so there's 23. Now we're moving on to 38. 38. Let's take a look at 38. 38 says find the tangents to the curve y equals x to the third plus x. Find the tangents to the curve at the points where the slope is 4. So part A, we want to know where slope equals 4. Well, that's the same as saying when does y prime equal to 4? I guess I need to find y prime first. Y prime is going to be 3x squared plus 1. And I want to know when y prime equals 4. So 4 equals 3x squared plus 1. Subtract 1 from both sides. And so I get 2/3 equals x squared, or x equals plus and minus root 2/3. And yes, AP would happily write that as root 6 over 3 because they split this into root 2 over root 3 and then rationalized. And you should be prepared for such shenanigans. So at these two x places, y has a slope of 4. But wait, there's more. What is the smallest possible slope of the curve? Whoa, well this has lots of different slopes. How can I know the smallest slope? Well, what's slope of y called? That's called y prime. So what we're really asking here is, when is y prime smallest? Or when does y prime have a minimum? Look at y prime. What kind of function is that? Hey, that's a parabola, shifted up one. Sure glad you have a graphical sense. Where is the smallest y value on this graph? Remember, this is our y prime graph. The lowest value happens here at x equals 0. So when x equals 0, slopes on y are a minimum. Or we have our smallest slope. The smallest slopes on this function happen here at x equals 0. I wonder if we could see that graphically. X squared plus 1. Ooh, no, I don't want to try and do that graph. Okay, well, wait a second. I actually could say something about that, couldn't I? I could say, this has zeros only at 0, because this is imaginary, and it's some kind of, no, that's not going to work. Yeah, I'm not going to do that. I'm just going to say, look at this derivative. We want to know when this derivative is smallest. Since this is an up-pointing parabola shifted up one, the smallest value on this parabola occurs when x equals 0. What is that value? That value is 1. I plug in a 0 here, I get 1. So I know the smallest slope on y is 1 at x equals 0. Okay, and I think there's a part C with this problem too. At what value of x does the curve have this slope? Oh, okay, so here's part B, the smallest slope is 1, and here's part C, at x equals 0. Okay, so there's 38. You might want to watch that again. That's a very reasonable AP test question. Next, 47. Ooh, we're almost done. 47 says, free fall. If a rock falls from rest on the surface near the surface of Earth, the distance it covers during the first few seconds is given by s equals 4.9 t squared. and these are in meters, and t is in seconds. Okay. What else do we know? Find ds dt and the second derivative. Dun, dun, dun. So they're asking me to take, with respect to time, the derivative of s. That's how ds dt comes around. I take the derivative of s with respect to t. The derivative of s with respect to t. So I have to also take the derivative with respect to t of 4.9t squared. Well, again, I have a constant times a function, and the derivative of a constant times a function will be that constant times the derivative of the function. The derivative of t squared is 2t, and so I get 2 times 4.9, or 9.8t. That's the first derivative. But now they want me to come back and take the second derivative. They want me to take the derivative twice of s, both times with respect to t. Both times with respect to t. In our class, it will always be both times with respect to this. In Calc 3, it could be different. It could be one time with respect to x and one time with respect to y, and that's going to be great. But all we need to do is take the derivative with respect to t of ds dt. That's what this notation says, find the second derivative. Well, that means I want the derivative with respect to t of 9.8t. Well, the derivative of this linear function is just going to be 9.8. And that's why we know that the first derivative of position would be velocity, and the second derivative of position would be acceleration, and there's acceleration due to gravity in metric land. Okay, so there's 47. Let's take a look at 53. 53 says, true or false, the derivative with respect to x of pi to the third equals 3 pi squared. No. False. Pi is a constant. This is a constant raised to a power. That's like saying, hey, what's the derivative of 2 to the third? Well, the derivative of 8 is 0. The derivative of any constant is 0. There's no x here. This isn't x to the third. This is pi to the third. This is just some constant. The derivative of a constant is 0. This is false because the derivative of a constant should be 0. 56. 56 says, let f of x be x minus 1 over x, x minus 1 over x, and find f double prime of x, f double prime of x. Well, in order to find the second derivative, I need to find the first derivative first, so let's do that. And I find rewriting this, I do not want to use quotient rule. Do not use quotient rule here. Put on the dunce cap if you use quotient rule here. Instead, rewrite that as x to the negative 1 power. Because now f prime is simply going to be the derivative of this, which is 1, and the derivative of x to the minus 1. Bring down that negative 1. 1 times negative is positive x, subtract 1. Minus 1 is minus 2. Okay, there's f prime, f prime. What about f double prime? Well, just take the derivative of this. Do not write this as 1 over x squared and take the quotient rule, crazy people. Instead, say the derivative of this is 0, and the derivative of this, I'll bring down the minus 2, and I'll subtract 1. If you want to now rewrite this as negative 2 over x to the third, you have my blessing. But please, for the sake of easy derivatives, use negative exponents. Don't leave this fractiony nonsense, okay? So that's 56. Oh, it's multiple choice. And 56 looks like There it is, D. Okay, and now we've got some AP. No, it's a quick quiz. A quick quiz for AP preparation. Let's go. Sometimes our book has little AP-like questions. Number 1, let f of x equals absolute x plus 1. Oh, that's our absolute value graph, shifted 1 to the left. Which of the following statements about f is true? F is continuous at -1. Well, we know what this looks like even without a calculator. And yes, this function is continuous at -1. Why? Because f of -1 exists, and the limit as x approaches -1 from the left is equal to the limit as x approaches -1 for the right. In fact, I think it's worth actually writing that out. F of -1 equals the limit as x approaches -1 of f of x. So we know that this is 0. We know that this limit is 0 because from both sides here, the function is approaching, the y values of the function are approaching 0. So we know that this function is continuous. Okay, what else? The function is differentiable at -1. Wait a minute. I know in order for differentiability to exist, the functions not only needs to be continuous, and we have continuous, but also the limit of the slopes as x approaches -1 from both the negative and positive side. Not the y values, but the slopes have to be the same. Well, the slope over here is 1, and the slope over here is -1. As we get closer and closer to this x value, are the slopes changing? No, they're always -1. So right here, the slope is -1. And over here, the slopes are always +1. So right here, the slope will be +1. The limit of the slopes from the left is -1. The limit of the slopes from the right is +1. Are those equal? No, they're not. So we know that 2 doesn't work. F is not differentiable at -1. And then finally, F has a corner at -1. Well, we see a corner there. And a corner occurs when the limit from the left doesn't equal the limit from the right. And so we know that 3 works. So 1 and 3 work, and so our choice then for 1 and 3 is D. D, 1 and 3 only. Okay, 2 is also multiple choice. The line normal to the graph of f of x at 1, 2 passes through this other point. Wow, there's a lot of information here. I'm going to erase and start fresh. Okay, number 2. The normal to the graph of f at 1, 2. So there's the point of tangency that I want to build this normal at. Also passes through the normal, passes through the point -1, 1. Which of the following could be f prime of 1? F prime of 1. Oh, so at the point of tangency, they'd like to know the slope. Okay, so what's true about the normal? The normal is perpendicular to the tangent line, and the slope of the tangent line and the slope of the curve are the same at the point of tangency. So what is the slope we have here going on the normal? 2 minus 1 over 1 minus a minus 1 would be 1 over 2. That's the slope of the normal. What would the slope of the tangent line be? Well, the tangent and normal are perpendicular to each other, so -2. So, if the tangent line has a slope of -2, the curve has a slope at the point of tangency of -2. So my answer here is -2, and that corresponds with A. You might want to read this problem again, watch the video 2 or 3 times. It's really quite an easy question when you actually understand that they're saying, look, there exists some function, that has a point of tangency, a tangent line at that point, but also a normal line at that point. The normal line will pass through the point of tangency and this other point. The normal line has a slope of y1 minus y2 over x1 minus x2, and the tangent line is perpendicular to the normal, so the tangent line has a slope of -2. And what's f prime mean? What's the slope of f at 1? Well, that's the same as the slope of the tangent at the point of tangency. So both of them would be -2. Let's take a look at 3. It looks to be a difference quotient problem. Find the derivative if y equals 4x minus 3 over 2x plus 1. So dy dx will be low d high minus high d low all over low squared. Okay, so let's tidy up the top because I notice the denominators aren't foiled in any of the A, B, C, D, or E choices. I'm going to have 8x plus 4 minus 8x minus a minus is plus 6 over 2x plus 1 squared. The 8x's cancel. Again, that doesn't always happen. We've just seen that a couple of times recently. And so I get 10 over 2x plus 1 squared. And 10 over 2x plus 1 squared corresponds with choice C. Choice C for number 3. Our last question, number 4, comes with a couple of parts. This is a great test question for us. F of x equals x to the 4th minus 4x squared. Find all the points where f has a horizontal tangent. Well, a horizontal tangent, I'm sorry, I'm just sort of lost in graphing a quick graph of f of x so that I can show you a horizontal tangent. A horizontal tangent is where the slope is 0. Looks like we have 3 horizontal tangents here. How do I find them? Well, it appears one of those horizontal tangents is at 0. But really, the best way to find a horizontal tangent is to find f prime and set f prime equal to 0. So what would f prime be? F prime is going to be 4x to the 3rd, that's the derivative of x to the 4th, and the derivative over here will be minus 8x. Can we factor? Sure, we can factor a 4x out, giving us x squared minus 2. Okay, so remember, we want to know when this function f has horizontal tangents. That's when f prime equals 0. So let's set this equal to 0, which means 4x equals 0, or x squared minus 2 equals 0. This happens when x equals 0, or when x equals plus and minus. Don't you dare forget to take that square root of 2. Find all the points where f of x has horizontal tangents. These are the places where f of x has horizontal tangents. B. For an equation, find the equation of the tangent line at x equals 1. So remember, we need a point, and we have half a point right now. We also need to know the y value there, and we need the slope at 1. So f of 1, I plug 1 in here, and I get f of 1 equals 1 to the 4th minus 4 times 1 squared, or -3. So I have this ordered pair, 1, -3, but now I also need f prime of 1. Well, here's f prime, and so f prime of 1 is going to be 4, 1 to the 3rd minus 8 times 1, which is -4. So what would the tangent line be? Y minus a minus 3 equals -4, x minus 1. And you can leave it there and walk away. And part C says, what's the normal line here? Well, the ordered pair is going to be the same. What's going to be different is our slope. Instead of using the slope of the curve, the normal will be perpendicular. So what will our perpendicular slope be? Positive 1/4. So y plus 3 equals positive 1/4, x minus 1, and there's our equation of the normal. Okay, 40 minutes, not bad for the homework. You should practice and get comfortable with that speed as well. Don't worry if you don't have it quite yet. I promise by the time you take the AP exam, you will glisten with speed and correctness. Humana, 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 hum. Okay, you go here, you go here, you go here. Did I drop anybody else? I don't see nobody else but me.